We've mapped the stars, walked on the moon, but how well do we really know the Earth beneath our feet? What lies under cities, mountains, oceans, and even our own homes? Welcome to Geophysics, the science that peers inside the Earth without digging a single hole. From predicting earthquakes to finding oil, from scanning for groundwater to understanding Earth's core, geophysics is the secret X-ray vision of Earth science. Let's dive into this fascinating world where physics meets geology. Geophysics is the branch of Earth science that uses physics-based techniques to understand the Earth's interior, from shallow soil to the planet's deep mantle. While geologists observe surface clues like rocks and layers, geophysicists rely on signals, waves, fields, and forces to detect what's underground. Seismology uses seismic waves to explore the Earth's interior and locate earthquakes. Devices used include the seismometer, which detects ground vibrations caused by seismic waves. It works like a super-sensitive microphone that records every tremor, even those too small for humans to feel. Geophones are also used in exploration to detect reflected seismic waves underground. These sensors pick up echoes from sound waves bounced off rock layers, similar to sonar. Magnetometry is all about sensing the Earth's magnetic texture. This branch measures variations in the Earth's magnetic field caused by underground rocks or structures. Devices used include the magnetometer, which measures the strength and direction of local magnetic fields. It detects how magnetic minerals in rocks distort Earth's natural field. There are also proton precession magnetometers, which are a highly accurate variant. They measure how fast hydrogen nuclei spin in a magnetic field, giving precise readings of magnetic anomalies. Gravimetry, weighing the Earth from above. Gravity actually varies subtly across the Earth depending on underground densities. Gravimetry uses these differences to map subsurface features. The main device used is a gravimeter, which measures tiny changes in gravitational pull. It uses springs or accelerometers to detect how much the Earth pulls downward, and, well, changes in these measurements reveal denser or emptier zones underground. Electrical and electromagnetic methods, mapping the Earth's conductivity. These methods help locate groundwater, mineral deposits, and even pollution zones based on how electricity flows underground. The main devices used include resistivity meters, which inject a small electric current into the ground via electrodes. They measure how strongly underground materials resist electric flow. Water conducts better than dry rock, for example. EM sensors, or electromagnetic induction tools, induce a magnetic field and measure its response. They can detect changes caused by buried conductive materials like metals or saline water. Ground-penetrating radar, or GPR, is used to detect shallow objects like pipes, voids, or archaeological structures. The GPR system, which includes an antenna and a control unit, sends high-frequency radio waves into the ground. When these waves hit buried objects or different materials, they bounce back, just like radar or even ultrasound, really. Geothermal methods are all about tracking Earth's heat flow. These techniques study how heat moves from Earth's interior up to its surface. The main devices used are thermal probes, which are inserted into boreholes to measure temperature at different depths. The deeper you go, the more heat you detect, and this really helps in locating geothermal energy zones. Then there are heat flow meters, which combine temperature gradients with thermal conductivity to actually quantify how much heat is moving underground. So, geophysics has a ton of real-world uses. For oil, gas, and mineral exploration, seismic surveys, along with gravimetric and magnetic data, help pinpoint deposits with high accuracy. When it comes to earthquake monitoring and hazard assessment, seismology maps fault zones and predicts seismic risk. For groundwater mapping, resistivity and electromagnetic methods help identify aquifers in dry regions. In civil engineering and construction, ground-penetrating radar and resistivity scans detect cavities, loose soils, and buried utilities before building even starts. Volcano monitoring uses seismic, thermal, and GPS data to track magma movement and eruption risk. And in archaeology and climate records, ground-penetrating radar and magnetometry can reveal buried ruins, old riverbeds, or even ancient shorelines. While geology studies rocks, minerals, and Earth's surface, features geophysics sees beneath the surface using invisible forces, like sound, heat, magnetism, and electricity. Together, they really do form the perfect team. The geologist says, "There might be oil here." And the geophysicist says, "Let me check," without digging. Geophysics is the science that lets us see the unseen. It powers clean energy, protects cities, uncovers history, and even guides space missions exploring other planets. So, share and subscribe for more powerful Earth science explainers. Next up, we go inside the ground-penetrating radar to understand how it works on real terrains. Stay curious, stay grounded.